In this video, I'd like to go over some examples of problems where we're trying to determine whether or not we would use independent group means, matched or paired samples, or a single mean to compute, to do a hypothesis test. This is similar to the first problems on homework 8. One of the things that I get asked about this homework problem is why is there a B, C, and D but no A? The reason is that we didn't cover the topic that the book used A for, so I eliminated that choice to reduce the confusion. But apparently that may have increased confusion. But I just eliminated the choice that we didn't go over. At any rate, let's take a look at these problems. And what we want to remember is that to distinguish between using independent group means and matched or paired samples, you want to know if there is a connection between the samples or between the variables. So let's look at the first problem. A university would like to compare the math SAT scores of male and female first-year students. 50 males and 40 females are selected at random, and their math SAT scores are recorded. So is this independent or dependent sampling? Well, first off, there are two samples. You have males and females. The second thing you want to, so it's not going to be a single mean. Second thing you want to know is this going to be paired samples or independent group means? Well, to determine that, we want to know if there is a connection between these 50 males and these 40 females. And for one thing, there are different numbers. There's 50 males and 40 females, so you can't pair them up. But in addition to that, nothing here says that there's a relationship. We're not choosing male and female people who are in relationships with one another. We're not sampling people who are married. So there's no relationship between the 50 males and the 40 females. And so the correct answer here, since it's two samples, and there's no relationship between the two samples, it's independent group means. Let's contrast that with this next one where you have university wanting to compare the math and verbal scores for first-year students. And 50 students are selected at random, and their math and verbal SAT scores are recorded. Now, in this case, there's a single sample, and that single sample is giving me two numbers. We're comparing the math and the verbal SAT scores. And so what I'm going to have is I'm going to have 50 math scores, one for each of the 50 students, and 50 verbal scores. But there's a connection between those 50 math and 50 verbal scores. And so, in a sense, they're connected. Well, they're definitely connected. Each student gives me one math score and one verbal score. Because of the connection between the math and verbal scores, this direct connection that each student gives me one of each, this is going to be dependent sampling, and I'll select this choice, matched or paired samples. It's not a single mean because you actually have two sets of numbers, math and verbal. Let's go on to the next problem. A cereal manufacturer claims that there's an average of 2 scoops of raisins for every box of cereal. A researcher buys 30 boxes of cereal and carefully separates out the raisins in order to test this claim. Well, in this case, this researcher has 30 boxes, 30 numbers. I assume that the researcher is going to measure the volume of the raisins found in each box and then compute an average. We have a single variable here. So this is not going to be independent group means because we only have a single sample. It's not matched or paired samples. Because you only have a single sample, there's only one choice for a single sample, and that is the single mean. The next one, in order to test whether she runs faster in the morning or the evening, a researcher times herself running 3 miles on 20 mornings and 20 evenings. So let's see, this researcher is going to run 3 miles on 20 different mornings and 3 miles on 20 different evenings. So you have two groups of numbers here, the morning runs and the evening runs. So I guess we can eliminate this choice. It's not going to be a single mean because you have two separate samples, two separate groups. The question is this matched or is it independent? Now, it's not entirely clear how she's doing this experiment, but being a runner myself, I can say that I probably would not choose to run 3 miles in the morning and the evening in a given day. I certainly wouldn't do that for 20 days. I'd choose to run 3 miles on 20 different mornings and then 3 miles again on 20 other evenings. Because of that, there is no matching or pairing between these mornings and evenings. You see, if the researcher had run, say, 3 miles in the morning on Monday and then 3 miles in the evening on Monday, then you could pair up those two runs. Both of those runs would be on the same day. But I don't believe that's what's happening, not only because I don't think it's what's happening, but also because I wrote this problem and that's not what I intended. I suppose that if you read this in the book, we would want to have a little bit more information here. So let's see. Maybe I'll put an extra little bit of information, and I'll make sure that the quizzes and the final exam are unambiguous. For this one, though, let me just add a little statement here. The 20 mornings were on different days than the 20 evenings. There. So that really clinches the deal here that we're definitely dealing with 20 different mornings and 20 different evenings. So there is no connection. There's no relationship between the mornings and the evenings. You might have run on the morning on Monday and then in the evening on Tuesday. So that those were two separate days. No connection between the mornings and the evenings. So this one is going to be the independent group means. Finally, one more problem, and that is the statistics professor interested in whether test scores decline during March Madness. He gives a test just before basketball tournament begins, and then gives a similar test the day after the final game of the tournament. In this case, I think we can assume, and maybe I should specify again, just to be clear, to the same class. There. That we're dealing with the same class, so that I have each of these students is going to take the test just before the basketball tournament and just after the tournament. So in this case, each person in the class, say Fred takes the test before and takes the test after. And so Fred is the connection between his before score and his after score. And then Wilma is going to take the test before and the test after. And then Barney is going to take the test before and after. So that you have each of these individuals, each of these students in the statistics professor's class connects one of the before scores with one of the after scores. And so this one is going to be a matched or paired sample, because you can match or pair the means. Well, I hope this was helpful, and let me know if there's other things I can do for you.